Hey guys, it's Miss Pruitt. So I wanted to do about 4 more examples on basic derivative rules. So this is basic derivative rules part 2. Here, I would like to take the derivative of this function, f of x equals x squared minus 2 divided by x squared. Well, we haven't learned how to really work with fractions yet. However, I know, because of my fraction rules, that I can rewrite this function. So that's the very first thing you want to do. And matter of fact, the first thing you want to do a lot of times is see if your function can be rewritten in a different way. So I know when I have addition or subtraction in my numerator that both terms can be separated by the minus sign, plus or minus sign, where they would have denominators that were in common. What I mean by that is I can separate this to be x squared over x squared minus 2 over x squared. Well, x squared over x squared just reduces to 1. And because I know I want to take the derivative, I want to move this x squared that's in my denominator to the top. We talked about that in the last video. That would make this minus 2x to the negative 2. So I'm ready to take the derivative of this. Let's pick another color. So what I'm really taking the derivative of is this. So the derivative of 1, or any constant, is going to be 0, minus the derivative of 2x to the negative 2 power. You leave your coefficient, you bring your exponent to the front, and you subtract your by 1 in your exponent. So this would be 0 plus 4 times x to the negative 3 power. 4x to the negative 3rd power. I do not want to leave, even though you can on the exam, but in this case I don't want to leave a negative exponent. It's only proper to put him in his proper place. So my answer would be 4 over x cubed. That's the answer. All right, next example. Again, I'm going to want to rewrite this. I don't want the square root of x to be in my denominator. I want to move him up here, or up to the top. And I want to pull out my coefficient, my fraction coefficient for the second term. So let's do that. I'm rewriting this equation. I just want to pick another color. So f of x, technical difficulties. F of x would be 2 x to the negative 1/2 power plus 1/2 x to the 1/2 power. I'm ready to take the derivative. So the derivative of f would leave me with 2 times negative 1/2 x to the negative 3/2 power plus 1/2 times 1/2 x to the negative 1/2 power. Coincidentally, this reduces to 1. Don't drop the negative though. Still 1 times negative 1. So this will be negative x to the negative 3/2 power plus 1/4 x to the negative 1/2 power. Cleaning that up because I don't really want to have negative exponents. This would be negative 1 over x to the power of 3 over 2 plus 1 over 4. I already have a fraction as terms right there. So leave that 4 down there and have this x to the 1/2 join. If I wanted to be fancy with it, it would be negative 1 over the square root of x cubed plus 1 over 4 times the square root of x. That's the answer. All right, time for another example. So this simply looks as if it is just power rule. Remember, it doesn't matter what is up here in my exponent. It doesn't matter what that is. You still follow the rules of the power rule. You bring whatever your exponent is down to the front and then subtract by 1 in the exponent. So my rule, if I'm looking for the derivative of this, and I am, so I'm looking for y prime, I would leave my coefficient in the front. It's not bothering anybody. I would bring down my exponent, which is 3/4 minus pi. Pi is not a variable. Pi is a number. So all of this is just a number. That'll leave me with x raised to the 3/4 minus pi minus 1 power. Let's see if I can make this up. There we go, minus 1. All right. I have a number outside of parentheses, so I'm going to distribute. That will give me 4/3 times 3 over 4 minus 4/3 times pi and don't forget you have x, and I have 3/4 minus pi minus 1. Well, I see at 3/4 that I can combine with this negative 1 on the end, so I'm going to rewrite this. Instead of subtracting by 1, I'm going to subtract by 4 over 4. Then I'm going to combine 3 over 4 minus 4 over 4. So, what do I get from here? I see that both of these reduce to 1, and both of these reduce to 1. And 1 times 1 is 1. So in the front, I would have 1 minus 4/3 pi. They do not, these numbers here do not reduce to 0. They reduce to 1 times x to the negative 1/4 minus pi. This can also be written as 1 minus 4/3 pi x to, then I can pull out this negative and it would be pi plus 1/4 or 1/4 plus plus pi. And for me, that's a good enough answer. Let's do one more really fast. So I have f of x equals the square root of x times x squared plus 1. So I am going to want to distribute. That's one way that we can do this. I can distribute the square root of x here and here. Later on, we'll find out how we can use the product rule in order to, it's kind of like another way for us to solve this when you're multiplying two functions. But I know that I can distribute this. I can rewrite the square root of x to have a rational exponent. So this would be x to the 1/2 power times x squared plus 1. Well, remember, when you are multiplying, because I'm going to distribute, I'm going to do x to the 1/2 power times x squared. And whenever you distribute, whenever you multiply and you have two bases that are alike with exponents, you add their exponents. So in this case, this would be x to the 1/2 plus 2 plus x to the 1/2. Well, if I rewrote this to be 4 over 2, and multiply by 2 over 2, I would get x to the 5 over 2 plus x to the 1/2 power. Now recall, all I'm doing is rewriting. I have not taken the derivative yet, but everything is set up now so that I can. So I want to take the derivative of x to the 5/2 plus x to the 1/2. I can take the derivative of both terms. So I'm going to actually now use my power rule, which says bring your exponent to the front and subtract your exponent by 1. Instead of 1, I'm going to rewrite my 1 to 2 over 2. Plus, again, do the power rule again, bring down that 1/2, and take your exponent and subtract by 1. I'm going to subtract by 2 over 2. This would give me 5 over 2x to the 3/2 power plus 1/2 x to the negative 1/2 power. And if I were being fancy, I would make my answer 5/2 times the square root of x cubed plus 1 over 2 times the square root of x. My negative here makes this x term go down to the denominator. And that's the answer.